In this video, you will learn some fundamental concepts of chemistry. What activities might occupy the day of a typical student? You may have done some or all of the following tasks: eaten some meals, drunk coffee or cola, taken a shower with soap, taken notes in a class, checked email on a computer, watched some television, ridden a bike or car, taken an aspirin to relieve a headache, and spent some of the evening having snacks and refreshments with friends. Perhaps, without your awareness, your life was touched by chemistry in each of these activities. What then is this discipline we call chemistry? Chemistry is the study of matter, its composition, properties, and transformations. What is this matter? Matter is anything that has mass and takes up volume. In other words, chemistry studies anything that we touch, feel, see, smell, or taste, from simple substances like water or salt to complex substances like proteins and carbohydrates that combine to form the human body. Some matter such as cotton, sand, and apple are naturally occurring, meaning it is isolated from natural sources. Other substances such as nylon, styrofoam, the plastic used in soft drink bottles, and pain reliever ibuprofen are synthetic, meaning they are produced by chemists in the laboratory. Matter can be described based on its state or phase, of which there are three main types: solid, liquid, and gas. Several new studies, however, have revealed the existence of the fourth and fifth states referred to as plasma and Bose-Einstein condensate. First, let us talk about solid. Solids have definite shape and volume. The particles in a solid are tightly packed together. Thus, solids are almost incompressible. The particles vibrate in a fixed position. They cannot move around or slide past each other. Solids have high densities and can expand only slightly when heated. Next, we have the liquid. A liquid has no definite shape but has definite volume. The particles in a liquid are close with one another but not as close as those in a solid. The particles are not arranged in a rigid or orderly manner. They can slide past each other, allowing the liquid to flow freely and take the shape of the container in which it is placed. Liquids are almost incompressible, but they tend to expand slightly when heated. They generally have medium density. Then, next will be gas. Like liquids, gases take the shape of their container. However, they have no definite volume. A gas can expand to fill any volume. Thus, it takes both the shape and volume of its container. The particles in a gas are usually much farther apart than those in a liquid. Because of the large space between the particles, gases are easily compressed into a smaller volume when pressure is increased, but they greatly expand when heated. Gases also have low densities. Plasma is the fourth state of matter. It is formed by heating and ionizing a gas. Plasmas are made up of groups of negatively and positively charged particles. Plasmas are not the same as gases. They have neither a definite volume nor a definite shape. They are often observed in ionized gases, aurora borealis or the northern lights, lightning, and comet tails. The fifth state of matter is the Bose-Einstein condensate. It is produced when a cloud of bosons, so this is a type of an elementary particle of matter. So when this cloud of bosons is cooled to temperatures very close to absolute zero, such that a large fraction of the bosons condense. Bose-Einstein condensates include superfluids like cold liquid helium and superconductors like the nucleons inside a neutron star. Now, let us talk about the properties of matter. Properties are the characteristics that gives each substance its unique identity. First, we have the physical property. Physical properties are characteristics a substance shows by itself without changing into or interacting with another substance. So a physical change occurs when a substance alters its physical properties, not its composition. Next is the chemical property. Chemical properties are characteristics a substance shows as it changes into or interacts with another substance or substances. So a chemical change, also called a chemical reaction, occurs when a substance or substances is converted into a different substance or substances. Next, we have the phase changes. Adding or removing energy from matter causes a physical change as matter moves from one state to another. So we have the following phase changes. First, which is melting. That is from solid to liquid. When heat is applied to a solid, its particles begin to vibrate faster and move farther apart. When the substance reaches a certain combination of temperature and pressure, which is the melting point, the solid will begin to melt and turn into a liquid. Next, we have freezing. That is from liquid to solid. When heat is removed from a liquid, its particles slow down and begin to settle in one location within the substance. When the substance reaches a cool enough temperature at a certain pressure, that is the freezing point, the liquid becomes a solid. Next, vaporization. That is from liquid to gas. Vaporization is the conversion of a liquid to a gas and can occur through either evaporation or boiling. So when liquid boils with enough heat, it will cause vapor bubbles to form below the surface. This boiling point is the temperature and pressure at which a liquid becomes a gas. Next, we have the condensation. That is from gas to liquid. Condensation occurs when a gas loses energy and comes together to form a liquid. For example, water vapor condenses into liquid water. Next, we have the sublimation, which is from solid to gas. So when a solid is converted directly into a gas without going through a liquid phase, the process is known as sublimation. This may occur either when the temperature of the sample is rapidly increased beyond the boiling point, or when a substance is freeze-dried by cooling it under vacuum conditions so that the water in the substance undergoes sublimation and is removed from the sample. A few volatile substances will undergo sublimation at room temperature and pressure, such as frozen carbon dioxide or dry ice. And the last one is deposition, which is from gas to solid. Deposition occurs when a gas transforms directly into a solid without going through the liquid phase. Water vapor becomes ice or frost when the air touching a solid such as blade of grass is cooler than the rest of the air. So those are the 6 phase changes. The following changes can be classified as either exothermic or endothermic change. First, we have the exothermic change. As the molecules of gas attract each other into a liquid and then become fixed in a solid, the system of particles loses energy, which is released as heat. Thus, condensing, freezing, and depositing are exothermic change. The other one is the endothermic change. Heat must be absorbed by the system to overcome the attractive forces that keep the particles fixed in place in a solid or near each other in a liquid. Thus, melting, vaporizing, and subliming are endothermic change. Matter can be classified either as pure substance or mixture. A pure substance is characterized by unchanging or specific composition. The two types of pure substances are elements and compounds. Element is the simplest type of matter that is composed only of one kind of atom. For example, elements carbon, oxygen, and copper are composed of carbon atoms, oxygen atoms, and copper atoms respectively. On the other hand, a compound is composed of two or more elements combined chemically in definite proportions. For example, a molecule of water by the formula H2O has two hydrogen atoms and one oxygen atom. Mixtures are made up of two or more substances that are only physically combined and can thus be separated into their components through simple physical means. They can either be homogeneous or heterogeneous. Homogeneous mixtures like salt water and air exist in a single phase. This means that the appearance, properties, and composition are uniform throughout a sample. While mixtures whose components are not evenly distributed in the sample and can thus be physically identified are called heterogeneous mixtures. Some heterogeneous mixtures, such as oil-water mixture, form layers of their constituent substances. Since mixtures are combined through physical means, their components can also be separated through physical methods, which rely on the differences in the physical properties of the components. First method is through magnets. Magnets are normally used to remove magnetic solids from the non-magnetic components of the mixture. For mixtures of liquid and heavy insoluble solids, Decantation is the most appropriate method to use. Decantation of sand-water mixture is carried out by gently pouring the water out of the container after the sand has settled at the bottom of the container. Some homogeneous mixtures, like salt water, may be separated into their components through evaporation, done by continuously heating the solution, leaving behind the solid component of the mixture. Volatile solids may be separated from non-volatile substances through sublimation. Naphthalene is separated from table salt using this process. Next, infiltration. A solid liquid mixture is allowed to pass through a filter, trapping the solid in it. Then, distillation separates miscible liquids of different boiling points such as ethyl alcohol and water. And the last method is chromatography. It is the method used to separate components of different degrees of solubility using a moving and a stationary fluid. This method works in separating the color pigments of inks. So those are some of the fundamental concepts of chemistry. Thank you for watching, and I hope you have learned something.